Hi students, now we are going to discuss about redox reaction in terms of oxidation number. Redox reaction. What is meaning of redox reaction? Reduction as well as oxidation takes place in a single reaction. Simultaneously takes place in a single reaction known as a redox reaction. What is meaning of reduction? What is meaning of oxidation? In different terms to explain the oxidation and the reduction process. First one, what is the meaning of oxidation? Oxidation is nothing but addition of oxygen, removal of hydrogen, oxidation number increases, or metal can be converted into metal cation, or loss of electrons known as oxidation. The process carried out in a reactor known as oxidation or reducing agents. Next one, reduction. What is the meaning of reduction? Removal of oxygen, addition of hydrogen, gain of electron. Metal cation can be converted into metal. Oxidation number decreases known as a reduction process. Those reduction process carried out in a reactor known as a oxidizing agent or oxidants. So, oxidation process as well as a reduction process takes place simultaneously in a single reaction known as a redox reactions. In a redox reaction, oxidation number of element can be changes. Oxidation number of element can be changes. For example, oxidation of potassium permanganate, KMNO4, potassium permanganate, is a react with ferrous sulfate, FeSO4, ferrous sulfate, in presence of concentrated sulfuric acid, H2SO4. Because of oxidation of ferrous sulfate in presence of potassium permanganate, this takes place in acidic medium. That's why in this reaction takes place in concentrated sulfuric acid medium. So gives in the potassium permanganate can be converted into potassium sulfate K2SO4 plus manganese can be converted into manganese sulfate MnSO4 plus ferrous sulfate can be changes into ferric sulfate Fe2SO4 thrice. Fe2SO4 thrice. Because of in the iron elements, iron metal can exist the two types of valency. One is a 2 plus valency and one is a 3 plus valency. 2 plus valency otherwise called ferrous, 3 plus valency otherwise called ferric. That's why in the FeSO4 in the named as the ferrous sulfate. Fe2SO4 thrice can be named as the ferric sulfate plus water molecules removed, H2O. In this equation, non-stoichiometric equation. Non-stoichiometric equation. What is the meaning of non-stoichiometric? Two types of reactions are there. Stoichiometric reaction, stoichiometric equation, non-stoichiometric equation. Total number of atom of element balanced on both sides of the reaction known as a balanced equation, balanced reaction or stoichiometric equation, stoichiometric process. Unbalanced reactant and product in terms of oxidation number in reactant and product chain known as non-stoichiometric or unbalanced equations. Non-stoichiometric equation. In this reaction, non-stoichiometric equations. Now we are going to balance the reactant and product chain. In the 2 moles of potassium permanganate can be react with the 10 moles of ferrous sulfate to form of in presence of 8 moles of sulfuric acid and 5 moles of ferrous sulfate and 8 moles of water molecules removed. In this equation, balanced equation or in the stoichiometric equation. Okay, stoichiometric equation. What is the meaning of oxidation process? In the compound which contain element is easily decrease the oxidation number as well as increase in oxidation number. Increase in oxidation number known as oxidation process, decrease in oxidation number known as reduction process. Okay. Now we are going to discuss about how to find out the oxidation number of element in the compounds. Potassium permanganate is a compound. Totally how many elements are there? Potassium, manganese, oxygen. 3 types of elements are there. Potassium always exists plus 1 oxygen state because of it is an alkali metal. Alkali metal exhibit the plus 1 oxygen state, alkali earth metal exhibit the plus 2 oxygen state. In the D block exhibit the variety of oxygen state with variable valency because of which contain number of unpaired electron, D orbital which contain unpaired electrons are there. In the P block elements shows the in the few number of oxygen state is depend upon number of paired up electron as well as the number of unpaired electrons are there. In this topic we have already discussed in lower classes. Okay. In then potassium is a alkali metal. Alkali metal. Alkali metal exhibit the plus 1 oxygen state. Alkali metals like lithium, sodium, potassium, rubidium, cesium, francium. Francium is a radioactive elements. Remaining elements are alkali metal. Because of those elements, always takes place from the alkalis. That's why in these elements otherwise called alkali metals. Lithium, sodium, potassium, rubidium, cesium, francium. Those elements always exhibit the plus 1 oxygen state. Next one, alkaline earth metal. Alkaline earth metal. Second A group elements. Alkali metal, then first A group elements. Alkaline earth metal, second A group elements. Second A group elements of beryllium, magnesium, calcium, strontium, barium, radium. Radium is a radioactive elements. Remaining beryllium, magnesium, calcium, strontium, barium are alkaline earth metal because of those elements of hydroxide compounds always obtained from the mining. Is always exists a basic substance. Okay. In the potassium is a alkali metal. In the potassium always exhibit the plus 1 oxygen state. That's why in the potassium oxygen of potassium can be expressed as plus 1. Next one, now we are going to discuss about or find out the oxidation number of manganese. So in the manganese can be expressed as a X. Then oxidation number of oxygen minus 2. Oxidation number of oxygen. The oxidation number of oxygen is carried out in different compounds. It is depend upon different linkage. Okay. Generally, oxidation number of oxygen minus 2 charge in general compounds. In peroxide, oxidation number of oxygen minus 1 charge. In superoxide, oxidation number of oxygen plus 1 divided by 2 half charge. In ozonoid, oxidation of oxygen minus 1 divided by 3 charge. Now here in the oxidation number of oxygen minus 2 charge. Totally how many oxygens are there? 4 oxygens are there. So 4 into minus 2 equal to minus 8. Minus 8 equal to 0 because of there is no charge on the compound. Suppose if the compound which contain minus charge or plus charge or 2 minus or 3 minus means equal to the respective charge represented. Okay. But in this compound there is no charge on that. That's why equal to 0. So X minus 7 equal to 0. X is equal to 7. So potassium permanganate which contain manganese exhibit the plus 7 oxidation state. Potassium permanganate which contain manganese exhibit the plus 7 oxidation state. Next one. Ferrous sulfate contain iron exhibit the plus 2 oxidation state because of ferrous means 2 plus, ferric means 3 plus. In this compound ferric sulfate which contain iron exhibit the plus 3 oxygen state, plus 3. Okay. Manganese sulfate contain manganese exhibit the plus 2 oxygen state because of manganese sulfate dissociate to form of manganese 2 plus and SO4 2 minus ion. That's why manganese sulfate which contain manganese exhibit the plus 2 oxidation state, plus 2 oxygen state. Now in the potassium permanganate can be changes into manganese sulfate. Potassium permanganate contain manganese exhibit the plus 7 oxygen. Manganese sulfate contain manganese exhibit the plus 2 oxygen state. Here plus 7 oxidation state of manganese can be reduced to plus 2 oxygen state of manganese sulfate. So here in this compound of manganese can be reduced to form of manganese 2 plus. That's why in this process known as a reduction process. Reduction. What is meaning of reduction? Oxidation number decreases known as a reduction. Here plus 7 oxidation number can be reduced to plus 2. That is why in this process reduction process. Another one, plus 2 oxygen state of ferrous can be changes into plus 3 oxygen state of ferric. Here oxidation number increases. In this process oxidation process. So both oxidation as well as reduction takes place simultaneously in a single reaction as a redox reaction. In this process, in this reaction is an example of redox reaction. From this reaction, manganese is reduced to form of manganese 2 plus. Potassium permanganate which contain manganese 7 plus ion can be reduced to form of manganese sulfate container 2 plus ion, manganese 2 plus ions. Okay. So in the manganese reduced to form of manganese 2 plus, this process, reduction process, ferrous sulfate act as a reducing agent. Okay. Next one. ferrous sulfate container Fe2 plus ion oxidized to ferric sulfate container Fe3 plus ion. So oxidation number increases means oxidation process. Here ferrous can be oxidized to ferric 3 plus ion. That is why oxidation number increases. The process oxidation process, potassium permanganate acts as a oxidizing agent. Potassium permanganate acts as an oxidizing agent. Ferrous sulfate acts as a reducing agent. Both oxidation as well as reduction takes place simultaneously in a single reaction or redox reaction. In this process, example of redox reaction. Okay. Next one, for important topic, types of redox reaction. Types of redox reaction. Types of redox reactions. Different type of redox reactions are there. First one, combination reaction. Combination reaction. What is the meaning of combination reactions? Two elements can combine to form of new product. For example, carbon burn in air to form of carbon dioxide is simple process. Already we have learned in lower classes. Magnesium metal burn in air to form of magnesium oxide MgO. In same magnesium metal is combined with nitrogen gas to form of magnesium nitride Mg3N2. In the lithium metal combined with nitrogen gas to form of lithium nitride Li3N. Then Li3N. Then in the methane, combustion of methane burn in air to produce in the carbon dioxide CO2 plus H2O. It is a combustion process. These reactions are an example of combination reaction. What is the meaning of combination? Combination is nothing but, so two or more elements can combine to form of new product known as a combination reaction. Here, oxidation number of carbon 0. In the carbon dioxide contain carbon exhibit the plus 4 oxygen state. Because of, in the carbon expressed as X, oxidation state of oxygen minus 2. Here 2 oxygens are there. So 2 into 2 equal to 4. So minus 4 equal to 0 because of there is no charge on the compound. So X which is equal to 4. So carbon single element exhibit the 0 oxygen state. Carbon dioxide contain carbon exhibit the plus 4 oxygen state. Oxygen state of oxygen 0. Oxygen state of oxygen in carbon dioxide minus 2 oxygen state. Minus 2 oxygen state. Here oxidation number of carbon increases from 0 to plus 4. Oxidation process. Oxygen state of oxygen reduced from 0 to minus 2 in the process reduction process. Both oxidation and reduction takes place in a single reaction. Next one. Oxygen state of magnesium 0. Oxygen of oxygen minus 2. Oxygen state of magnesium plus 2. 0. Here 0. Oxygen of magnesium plus 2. Oxygen of oxygen in magnesium oxide minus 2. Here, oxidation number increases from 0 to plus 2. Another one, oxidation number decreases from 0 to minus 2. In this process also redox process. Next one, oxidation number of magnesium 0. Here, oxidation number of magnesium plus 2 in magnesium nitride. Oxidation number of nitrogen 0. Oxidation number of nitrogen in magnesium nitride minus 3. Minus 3. Here, in the magnesium oxidized to plus 2 oxygen state. Another one, nitrogen reduced to minus 3 oxidation state. It is also redox process. Next one, oxidate of lithium 0. Here, oxidate of lithium plus 1 charge. Oxidate of nitrogen 0. Here, oxidation of nitrogen in lithium nitride minus 3. So, oxidation number of lithium increases from 0 to plus 1, oxidation process. Nitrogen decreases from 0 to minus 3, reduction process. Another one, oxidation state of carbon minus 4. Here, oxidation of carbon plus 4. Oxidation state of oxygen 0. Here, oxidation state of oxygen minus 2, here also minus 2. So, oxidation number increases from minus 4 to plus 4. Another one, oxidation number of oxygen decreases from 0 to minus 2. So both oxidation as well as reduction takes place in all reaction. Redox reaction. In this example, is a redox process. It takes place in a combination reactions. Another one, in the decomposition reaction. Decomposition reaction. Decomposition reaction. The decomposition reaction is the opposite reaction of a combination reactions. Redox reaction in which in the single compound break to form of a two or more elements or two or more new compounds known as a decomposition process. For example, potassium chlorate KClO3 is a decomposed form of potassium chloride KCl plus oxygen gas removed. Single compound. In H2O water molecule dissociate to form of H2 plus O2. Calcium hydride CaH2 dissociate to form of calcium metal plus nitrogen gas removed. Sodium hydride NaH dissociate to form of sodium metal plus hydrogen gas. Single compound of potassium chloride, water, hydrogen, calcium hydride and sodium hydride. Single compound break or decomposed to form of potassium chloride, hydrogen, calcium, sodium respectively. In this process, redox process takes place in a decomposition reaction. So in the decomposition reaction is the reverse reaction of a combination reaction. Already I told to you, combination reaction means two elements can combine to form of a product. Decomposition reaction means a single compound break to form of two or more products. Okay. Potassium chlorate. What is the oxygen state of chlorine in potassium chlorate? Find out the oxygen state of chlorine in potassium chlorate. In potassium is alkali metal. Alkali metal oxygen state plus 1 charge. 1. Chlorine can be expressed as X. And in oxygen shows the minus 2 oxygen state in all compounds except peroxide, superoxide, ozonide, in any other compounds. In these compounds is not a peroxide, superoxide, ozonide. So oxidation number of oxygen minus 2 charge. How many oxygens are there? 3 oxygens are there. 3 into minus 2 equal to minus 6. Minus 6 equal to 0 because of there is no charge on the compound. So X minus 5 equal to 0. X is equal to plus 5. Potassium chlorate which contain chlorine exhibit the plus 5 oxidation state. Plus 5 oxygen state. Potassium chloride contain chlorine exhibit the minus 1 oxygen state. Minus 1. Potassium chloride contain oxygen exhibit the minus 2 oxygen state. Here product contain oxygen exhibit the 0 oxidation state. So plus 5 can be converted into minus 1. Oxidation number decreases, reduction process. Minus 2 can be converted to 0. Oxidation number increases, oxidation process, redox reactions. Next one, water molecule contain oxygen exhibit the minus 2 charge. Hydrogen exhibit the plus 1 charge. Hydrogen individual molecule 0, oxygen also takes place in 0 charge. Plus 1 can be converted to 0, oxidation number decreases, reduction. Minus 2 can be converted into, plus 1 can be converted to 0. Plus 1 can be converted to 0. In the process, reduction process because of oxidation number decreases, reduction process. Minus 2 can be converted to 0, oxidation number increases, the process, oxidation process. Another one, calcium hydride contain calcium exhibit the plus 2 charge. Hydrogen exhibit the minus 1 charge because of it is a hydride. Calcium metal 0, hydrogen also 0. Minus 1 can be converted to 0, oxidation. Plus 2 can be converted to 0, reduction, redox reaction. Another one, sodium hydride which contains sodium exhibit the plus 1 charge because of alkali metal. Hydrogen exhibit the minus 1 charge because of it is a hydride. Sodium individual element 0, hydrogen also 0. Oxidation number decreases from plus 1 to 0, reduction. Oxidation number increases from minus 1 to 0, oxidation. So, single compound break to form of 2 or more new compounds or elements known as a decomposition reaction. The process, redox process takes place in a decomposition reaction. Next one, displacement reaction. The compound which contain atom ion molecule displace the another compound contain atom ion molecules known as a displacement reaction. The displacement reaction is based on the electrochemical series. It is depend upon single electrode potential, single standard electrode potential. In the depend upon activity series or standard electrode potential, more reactive metal displaces the less reactive metal from the compound or solution. Okay, it is known as a displacement reactions. Two types of displacement reactions are there. One is a metal displacement reaction, another one non-metal displacement reactions. First one, metal displacement reaction. Metal displacement reactions. Metal displacement reactions. What is the meaning of metal displacement reactions? For example, zinc metal is dipped in or zinc rod or zinc bar or metallic zinc strip is dipped in copper sulfate solution. What is the color of the copper 2 plus ion? Copper sulfate solution means blue color. Now, in the zinc rod dipped in copper sulfate solution means in the blue color solution of copper sulfate can be changed into colorless. Simultaneously, in the brown colored metallic copper is deposited on the zinc rod. Here, zinc metal displaces the copper from copper sulfate solution. Zinc metal dipped in copper sulfate means to form of zinc sulfate ZnSO4 plus copper metal. Copper can be removed. In the color of the copper sulfate is blue color. Color of the zinc sulfate means colorless. So, blue color solution of copper sulfate can be changed into colorless when zinc rod dipped in copper sulfate solution. Here, zinc is a more reactive metal. Those more reactive metal of zinc is easily displace the copper from the copper sulfate solution. Another one, aluminium metal react with chromium reaction Cr2O3 gives aluminum sulfate Al2O3 plus chromium metal can be removed. Then, in the calcium metal react with vanadium monoxide V2O5 gives in the calcium oxide CaO plus vanadium solid element can be removed. Then magnesium metal react with titanium tetrabromide to converted into magnesium bromide MgBr2 plus titanium. Magnesium bromide plus titanium. What is oxide of zinc? 0. What is oxide of zinc in zinc sulfate? 2 plus H. What is oxide of copper sulfate? Copper sulfate 2 plus. Oxide of copper 0. Oxidation number increases from 0 to plus 2. Oxidation number decreases from plus 2 to 0. Redox reaction. Oxide of aluminium, calcium, magnesium 0 because of it is a simple elements. Oxide of chromium in chromium reaction plus 3. Oxide of vanadium in vanadium monoxide plus 5. Oxide of titanium in titanium tetrabromide plus 4 can be changed into oxide of aluminium in aluminium reaction plus 3 0, 0, 0. Oxide of calcium in calcium oxide plus 2. Oxide instead of magnesium bromide in magnesium bromide plus 2 charge. So, oxidation number increases from 0 to plus 3 oxidation process. Oxidation number decreases from plus 3 to 0 reduction process. Here, oxidation number of calcium increases from 0 to plus 2 oxidation process. Oxidation number of vanadium decreases from plus 2 to 0 reduction process. Oxidation number of magnesium increases from plus 2 to plus 0 to plus 2 oxidation process. Oxidation number of titanium reduced from plus 4 to 0 is a reduction process. So, in the reduction as well as oxidation takes place simultaneously in a single reaction known as a redox reaction as we know. Here, single metal element displaces the in the compound contain another metal to form of new compounds are formed. In this the process always takes place is based on the standard reduction potential or standard half cell. Here, in the zinc, aluminium, calcium, magnesium more reactive than copper, chromium, vanadium, titanium respectively. That's why zinc displaces the copper from copper sulfate, aluminum displaces the chromium from chromium trioxide, calcium displaces the vanadium from the vanadium monoxide, magnesium displaces the titanium from the titanium tetrabromide. In this process, metal displacement reaction, one metal displaces the another compound contain a metal. So more reactive metal displaces the less reactive metal from the compound or solution known as a metal displacement reaction. Another one, non-metal displacement reaction. Non-metal displacement. Non-metal displacement reactions. What is meaning of non-metals? Already we have learned in lower classes difference between metal and non-metal in 8th and 7th and also. Non-metal displacement reaction, maximum hydrogen, carbon, nitrogen, oxygen, in fluorine, chlorine, bromine, iodine, in n cases fully, oxygen, sulfur, selenium, these phosphorus, these elements are non-metals. Metal displaces the non-metal from the solution or compounds known as non-metal displacement reactions. Here, in the non-metal displacement reaction also takes place in different species. First one, more reactive metal. Another one, less reactive metal. More reactive, less reactive metal. Third one, in the moderate metal, moderate reactive metal. Then some other metal. Then in the least reactive, very less reactive. Very less reactive metals. More reactive metal. All alkyl metals are more reactive metal because of very low ionization energy. All alkyl metals. Another one, some alkaline earth metals. Example, potassium and barium. Potassium, then barium. Alkyl metal, alkyl earth metal. In the potassium and barium is easily react with in the cold water to produce the dihydrogens. So potassium react with cold water, barium react with cold water to produce hydrogen gas. So potassium can be converted to potassium hydroxide, and then barium can be converted into barium hydroxide, and the liberation of a hydrogen gas. Hydrogen gas is removed. In this process also redox reaction, redox process. Next one, in the less reactive metal, in for example magnesium and iron metal. Magnesium, Mg, and iron metals are less reactive metal. These less reactive metal do not react with cold water, but is easily react with steam to liberate hydrogen gas. Steam, H2O, steam vapor, oil vapor, to form of magnesium hydroxide, MgOH twice and liberation of hydrogen gas. Ferrous hydroxide, FeOH twice or oxides are formed. Fe2O3 and liberation of hydrogen gas. This process also redox process. So less reactive metals. Moderate reactive metal. The same elements of magnesium and iron and zinc also. Magnesium, iron, zinc metal is a moderate reactive metal. Those metals do not react with cold water, but is easily react with dilute acid to liberate hydrogen gas. So for example, zinc metal Zn is easily react with hydrochloric acid HCl to liberate the hydrogen gas. Zinc chloride ZnCl2 and hydrogen gas are moved. Magnesium metal Mg is react with hydrochloric acid HCl to produce magnesium chloride MgCl2 and liberation of hydrogen gas. Another one is a moderate reactive metal. Some other metals, cadmium and tin, cadmium Cd and tin Sn is do not react with in the what? Cold water as well as steam, but is easily react with dilute acids to liberate the hydrogen gas. Dilute acid, HCl, hydrochloric acid, HCl, dilute mineral acids to form of cadmium chloride, Cd, Cl2 and liberation of hydrogen gas. In then stannous chloride, SnCl2 and liberation of hydrogen gas. Dihydrogen gas are moved. Okay, these some other metals. Very less reactive. For example, silver, argentum, silver metal, Rm, Au, platinum, Pt, silver, argentum, silver, Rm, platinum, argentum, Rm, platinum, cold platinum. In these metals are very less reactive metals. Those metals do not react with cold water as well as warm water or even what steam, even dilute acid also. So in these metals do not liberate the hydrogen gas. These processes all are non-metal displacement reactions. Non-metal, hydrogen on metal, hydrogen on metal, hydrochloric acid contain hydrogen on metal. Water molecule contain hydrogen is a non-metal. Those non-metal displaced from the water or hydrochloric acid by using in the metals. This process is a redox process. Those redox process always takes place in a non-metal displacement reactions. Okay. Next one, disproportionation reactions. Disproportionation. What is the meaning of disproportionation reaction? Same compound which contain same element exhibit the increase in oxidation number as well as the decrease in oxidation number. So both oxidation as well as the reduction process takes place same compound containing same elements known as a disproportionation reaction. For example, hydrogen peroxide H2O2 dissociate to form of H2O plus O2. Another one, phosphorus P4, because of atomicity of phosphorus 4. So P4 always expressed as a P4. React with sodium hydroxide NaOH in presence of water molecule H2O to form of phosphine PH3 and sodium hypophosphite is removed NaH2PO2 sodium hypophosphite. Then sulfur S8 because of sulfur atomicity of sulfur 8. So always it expressed as a S8. So react with sodium hydroxide NaOH to give sodium sulfide Na2S plus sodium thiosulfate Na2S2O3 and water move H2O water molecule. Then Cl2 react with sodium hydroxide to produce sodium chloride NaCl plus sodium chlorate NaClO3 and water molecule H2O. Phosphorus can be converted to phosphine and sodium hypophosphite. Sulfur can be converted to sodium sulfide and sodium thiosulfate. Chlorine can be changed into sodium chloride and sodium chlorate. What is oxidation of hydrogen in hydrogen peroxide? Plus 1. What is oxidation of hydrogen in water? Plus 1. There is no change of oxidation of hydrogen in hydrogen peroxide as well as a water molecule. Okay, no problem. It is not a oxidation, reduction, redox reaction. Okay, next one. What is the oxygen state of oxygen? H2O2 is a hydrogen peroxide. Hydrogen peroxide. Hydrogen, oxygen, oxygen, hydrogen. It is a structure of hydrogen peroxide. Already we have learned in hydrogen lesson. Hydrogen, bond O, bond hydrogen means a peroxide linkage. Those peroxide linkage which contain oxygen exhibit the -1 charge. Each oxygen exhibit the -1 charge. So oxygen state of oxygen in hydrogen peroxide -1. Oxygen state of oxygen in water molecule -2. Oxygen state of oxygen 0. Here oxidation state of oxygen in hydrogen peroxide increases from -2 to 0, -1 to 0. Another one decreases from -1 to -2. So hydrogen peroxide which contains same element of oxygen shows the increase in oxidation number of 0 as well as a decrease in oxidation number of -2. This is the process known as a disproportionation reaction. Another one. Phosphorus 0 oxygen state. Phosphine -3 oxygen state because of hydrogen plus 1 charge. That's why how many hydrogens are there? 3 hydrogen. 3 into plus 1 equal to 3. So phosphorus exhibits the -3 oxygen state. Next one. Sodium hypophosphite NaH2PO2. NaH2PO2. How many sodium? 1 sodium. Each sodium exhibits the plus 1 charge. How many hydrogen? 2 hydrogens are there. Hydrogen also shows the plus 1 charge. 2 hydrogen. 2 into 1 equal to 2. Then phosphorus expressed as a X. Oxide of oxygen minus 2. How many oxygens are there? 2 oxygen. 2 into minus 2 equal to minus 4. Minus 4. In the compound contained, there is no charge. That's why equal to 0. 3 plus x minus 4 equal to 0. X minus 1 equal to 0. X is equal to plus 1. So oxidation state of phosphorus in sodium hypophosphite plus 1 charge. Plus 1 charge. Here, oxidation number increases from 0 to plus 1. Oxidation process. Oxidation number decreases from 0 to minus 3. Reduction process. Same element X will be both oxidation as well as reduction. Next one. Oxidation number of sulfur 0. Oxidation of sulfur in sodium sulfide minus 2. What is oxidation of sulfur in sodium thiosulfate? Find out the oxidation number of sulfur in sodium thiosulfate. Sodium Na2S2O3. 2 sodiums are there, so 2 sulfurs are there, 2x, 3 oxygens are there, minus 6 equal to 0, 2x minus 4 equal to 0, 2x which is equal to 4, x which is equal to 4 divided by 2, 4 divided by 2 which is equal to 2. So, oxidation state of sulfur in sodium thiosulfate plus 2 charge, plus 2 charge. So 0 can be oxidized to plus 2. 0 can be reduced to minus 2. Redox reactions. Next one. Oxidation state of chlorine 0. 0 oxidation state. Here, oxidation state of chlorine minus 1 charge. Another one. What is oxidation of chlorine in sodium chlorate? Sodium oxidation state plus 1 charge. 1. Chlorine expressed as a X. How many oxygen? 3 oxygen. 3 into minus 2 equal to 0. 6 which is equal to 0. X minus 5 equal to 0. X is equal to 5. X is equal to 5. Here, chlorine X will be plus 5 oxidation state. Chlorine X will be plus 5 oxidation state. 0 can be converted to minus 1 reduction. 0 can be converted to plus 5 oxidation. So, chlorine molecule X will be both oxidation reduction. Sulfur molecule X will be both oxidation reduction. Phosphorus X will be both oxidation reduction. Hydrogen peroxide which contain oxygen also exhibit the both oxidation reduction. So same compound which contains same element exhibit the increase in oxidation number as well as decrease in oxidation number. Both the oxidation as well as reduction process takes place in a same compound which contains same elements known as disproportionation reactions. Last one, competitive electron transfer reaction. Competitive electron transfer reaction. Competitive electron transfer reaction. What is meaning of competitive electron transfer reaction? We have already learned metal displacement reaction. Zinc metal dipped in blue color of copper sulfate solution. In the blue color of the copper sulfate solution can be changed into colorless substance of zinc sulfate. In this process, metal displacement. Now, if copper rod dipped in zinc sulfate solution means copper rod Cu dipped in zinc sulfate HNSO4 to give copper sulfate CuSO4 plus zinc metal can be removed in the process. Okay. Copper rod dipped in zinc sulfate solution means to form of copper sulfate. Because of in this reaction, copper 2 plus ion move into the solution to form of blue colored solutions are created. But in these changes does not observe. In this process does not take place. Because of zinc is more reactive than the copper. Zinc only displaces the copper from copper sulfate solution. Copper is less reactive than the zinc. That is why copper metal do not displace the zinc from the zinc sulfate solution. From this equation we concluded that zinc metal strong tendency to remove the electron. Copper metal strong tendency to accept the electrons. Don't forget, zinc metal strong tendency to release the electron. Copper metal strong tendency to attract the electrons. In the process always it takes place in a Daniell cell and a galvanic cell. So Daniell cell and galvanic cell also produce the electricity based on the zinc dipped in zinc sulfate solution, copper dipped in copper sulfate solution. Two metal electrode externally connect through wire. The electrons are migrated from the zinc to copper. Electric current produced or electric current move from copper to zinc. In the process, in the principle always takes place in a galvanic cell. Galvanic cell contain a reaction also one of the redox reactions. Okay. Next one. Suppose in the copper rod tipped in silver nitrate AgNO3. Copper rod tipped in silver nitrate solution means to form of a copper nitrate CuNO3 twice plus silver cell. In this process takes place. In this reaction is easily observed because of copper is more reactive than the silver. For example, according to electrochemical series, in the reduction potential of copper is a plus 0.34 voltage. Plus 0.34 voltage. Zinc minus 0.762 voltage. Silver plus 0.88 voltage. 0.88 voltage. So, negative reduction potential increases, reducing agent process, reducing tendency also increases. That's why in this process zinc metal acts as a powerful reducing agent, copper acts as a in the moderately oxidizing agents. Okay. Now, if copper rod tipped in silver nitrate solution, copper rod tipped in zinc sulfate solution means in the process or reaction do not take place because of in the zinc is a strong tendency to release the electron, copper is a strong tendency to accept the electron. Now, in then what? If copper rod tipped in silver nitrate solution means to form of a blue colored solution of copper nitrate and silver metals are formed. Copper nitrate. Okay. From this process, we can conclude that in the copper strong tendency to release the electron, silver metal strong tendency to accept the electrons. So, from these two equations, we can conclude that in the strong tendency to release the electron in this order of zinc metal is greater than copper metal is greater than silver metal. Based on this in this equation is what activity series can be created. According to activity series, zinc is more reactive than the copper, copper is more reactive than the silver, zinc strong tendency to release the electron, then copper strong tendency to release the electron, then silver strong tendency to accept the electron. Okay students, today topic over. Next topic we will meet the next video. Thank you.